Hey yo, what is up guys, Akarsh here back with another video, and today we'll be testing our antennas. These are antennas that you use on LoRaWAN gateways, hotspots, your Helium miners, your EdgeX miners and whatnot, even your Wi-Fi antennas. And we'll be using this NanoVNA that we received from Leap IoT. This is a pretty fancy device. It is just like your multimeter but for RF signals, and you can see where your antenna performs the best or at what frequency is your antenna tuned for. Also, you'll get to know if using a particular antenna is good for your Helium miner or not. So if that is something that you would want to learn about, subscribe to this channel for more content like that and stay tuned to the video. I order all my PCBs from jlcpcb.com. They offer 10 PCBs for $2 only. They also offer quick turnaround time and 24-hour production period. To design a PCB, you can use Easy EDA and then generate Gerber files for your project. Now upload the Gerber files on JLCPCB and get your PCB manufactured for cheap. They are currently also offering discounts on shipping. So now we'll look into what's inside the box of the SAA-2N, what comes inside. We'll unbox the product. If you're not interested in looking at the unboxing and knowing about the features of this VNA and directly jump into the practical part wherein we'll test the antennas, do jump to this timestamp or jump to the next chapter in this video. So moving on, when you open the box, you will find a good leather feeling pouch inside it. There's a control pick inside it as well, using which you control the touchscreen, and there's a short user manual. There's nothing else apart from this in the box, so I'll keep the box at the side. The user manual is a menu map firmware, so it kinds of is a mind map of from which menu you can go to where. So you might need this. It might come in handy if you're using all of the features of the VNA, but in this video I'll be letting you know how exactly can you use the menu. So this is kind of a good pouch, so it's like a purse, so you can carry it wherever you want for your sneaky testing. We'll quickly open the zipper. Directly we are greeted with these heavy cables. I'll take them out. These are really heavy, good quality cables that come in. There are these three things as well, and there is the main device. It's pretty heavy, I must say. It's a beefy device, and that's a good pouch. I'll keep this to a side, but it has a significant weight to it. First of all, these are three components or three connectors, you may say. These are for calibrating the SAA-2N NanoVNA, and so if we remove these caps, each of one has a label on it. This is open, this is load, and this one should be short. There you go, it's short. We'll be using these to calibrate the VNA real soon. Apart from that, you get a USB cable. So if you don't know, this has a micro USB port using which you can charge the device. Along with that, it is a USB compatible device because it has its own Qt software. So if you connect it to your computer, you can not only use the screen but also use the screen on your laptop. Do more advanced calculations using the software. So that is what the USB cable is for, and we'll be using this in a later part of the video where we'll be looking at the software. So as you must have noticed, the NanoVNA that we have has N type ports. So it's not the small it's not the regular small SMA connectors. It's the good beefy N type ports. So for that we have N type female to female cables over here. We have a couple of them for 2 ports. You can connect it directly over here and connect your antenna. You also get a male to male connector, so which can be used like an extender as well. So we have 4 components in total. I generally use one cable always connected to this, so it's kind of an extender to this port for my Helium LoRa antennas. I'll test those in a while. I'll keep these cables to a side for now, and for the grand reveal. It was a pretty crappy screen protector anyways. So that's a screen. It feels like a resistive screen. The entire body of the device is a metal thing. You see it's written the model number, that's the SAA-2N. This is the V2 version. So you see V2_2. There's the serial number. The frequency band or the bandwidth that this network analyzer can handle is from 5 kilohertz to 3 gigahertz. So that is why this is like a very good and a very preferred portable VNA, because it has a wide band. Not only you can test your Helium antennas, but you can test your 2.4 gigahertz Wi-Fi antennas on this as well. It has a good metal body. It has some labeling over here. So this is your channel 0, this is your channel 2, port 1, port 2, and then you have the network parameters over here. You have 3 buttons for guiding onto the menu. There's nothing much on the right hand side. There's a micro USB port on the top, and there's this power button on the left hand side. So we'll quickly power this on to check if it has battery or not. It indeed has battery in it, so we are directly greeted with the main menu. It looks a little bit like an oscilloscope, but it's very different from it. It has a high gloss display, I must say. There's this LED on the back. When it's on, it has turned on, and that's about it. Now we'll get on to the calibrating this NanoVNA. So I'll give you a closer look of the NanoVNA. So having a closer look at this, we can use the pick that we are provided with it for the menu. If you touch it, the menu pops up. If you touch it again, they close off. So there are 4 markers that you'll always see on the screen, 1, 2, 3, 4, with 4 different colors. So these are display markers. You also see the Smith chart at behind. And with this device, there are a lot of things, and not only antenna testing that you can do, because it has 2 ports. You can test band pass filters, any type of RF filters, your devices, your cables for cable loss and things like that, and of course antennas as well. You can even input a signal onto here, watch that RF signal very closely, and so the usabilities of this are endless. To use this for testing any antenna or essentially doing anything, you first need to calibrate it, as the calibration might be off. So we'll start with calibrating this. So there are different options. You need to hit the calibrate, and then you first need to hit the reset, so all the calibration gets resetted. You can also hit reset all. It's kind of playing the same function right now. Then you hit the calibrate button, and there are 3 options that we need to use: open, short, load, and over here are what we have. So first we need to go back. I'll quickly go to display and flip display so that I'm able to use it properly while playing with the things. So now we go back, we go to calibrate, we hit calibrate. Now we connect the open connector over here and hit open. It'll take a while, and when it's done as tick, it's connected as open, and you will see a small O popping up over here as well. I'll quickly disconnect this, keep it at a side, connect the short one. It's nice and tight. I'll click short. I'll wait again a couple of seconds for it to get tick mark, and an S appears on the left hand side over here. I'll disconnect the short and connect the load. Now I click the load. Once the tick mark appears and I see the L sign over here, I click done and I save it somewhere. There you go, it's saved. It says C0, that's calibration 0 setting. I'll remove the load, and now we have the device calibrated and ready to essentially go and test out antennas. For that, now we need an antenna. So I'll start with a crappy antenna that I know, because I bought it off a Chinese website for a very low price. Didn't get a good range out of it. So I have a connector over here which is an SMA to an N type. So I'll first connect my antenna to it, and now I'll connect the connector to the VNA. So I have my antenna connected to the connector converter, you may say, and then connected to port 0. Now before we can see or view the charts, we need to go and do some settings. So instead of the 4 displays, we only need 2. So first I'll go back to the main menu. I'll select the marker trace. I'll uncheck the third trace and the second trace. We only need 2 traces. The first one is a log mac, which we do need. Now I'll select the second trace, go back, and for the second trace we need a SWR, or a standing wave ratio, which essentially is a very important thing that we use in determining the antenna efficiency. So once we have selected trace 1, I'll go and firstly select channel 0 because we are plugged into channel 0. There you go, it's there. Then we select the format as SWR. This is important. Once we select SWR, you see there's a dip over here along with the dip in the yellow log mac line. But we need to be sure of the frequency range. Right now the frequency is starting at 100 and ending at 900, which is good enough. But in case this is not the case for you, you need to go back over here to the main menu, go to stimulus. You need to set the start frequency. So over here I'll set it as 300 megahertz. There you go. And we can also set the stop frequency or the upper limit. I'll keep it as 1000 megahertz. There you go. So now as you can see, it says 300 megahertz to 1000 megahertz. And now you can use the buttons over here, the right hand side button, to move the trace towards the right. As you see, while we move the trace towards the right, this also changes, this value also changes, and our frequency also changes. So what is essential is seeing where the dip is for the particular antenna. So dip is present somewhere around here, and the value of the dip is 1.94 or around 2. So this is the SWR ratio. Ideally this should be 1 for a perfectly good antenna. 1 means it should touch somewhere around over here or at the x-axis, and the point where this particular blue curve or the SWR curve is the minimal, that is the frequency for which the antenna will perform its best. So for this antenna, because we are seeing that the curve is at its minimal at around 447 megahertz, and the minimal is also 1.9, which is not a very good SWR. So as I mentioned in the starting, that this is not a very good antenna, and I didn't anticipate it to be a very good antenna. For $2, this is what you get. So we'll be looking at a better antenna as well. So I'll just remove this. Ideally this was labeled as a 433 megahertz, but we saw that it's not a very good antenna, and hence if you're connecting an antenna like this with your LoRa systems, you are not getting a very good signal strength and a range. And if you're into the helium mining stuff, forget about your rewards. This is an antenna that we'll be testing next. It's a standard antenna from Rack Wireless that comes with their gateways, and it's labeled for 863 to 870 megahertz. Let's test this out. How does this look? I'll quickly connect this to my channel 0. While changing antennas, it's not necessary to recalibrate the device. So I've connected this antenna, and straight over we see that there's this dip over here. We actually see 2 dips. So there's this dip over here as well. To kind of see this particular dip as well, we'll go back to the stimulus and we'll set the start frequency now as, let's say, 200. Last time we had set it as, there you go, we can see this dip as well. Now if we move the cursor, so at 296 megahertz we see a standing wave ratio of 1.2, and that is a very good ratio. So and we do see a wider or a less narrower peak over this side of the spectrum as well. So I'll quickly get over there, and it's 864 megahertz, so it's kind of the same frequency band for which it's rated, and you see that the SWR over here is around 1.5, which is better than the SWR of 1.9. And because we see a bigger valley technically over here, so it's kind of adjustable for other frequencies. So if I were to use it for the European band, that is the 868 megahertz, it's somewhere in between, which we cannot reach right now, but it's a 1.2 or a 1.3 SWR, which is comparatively better than what this cheap antenna had, considering that for the same frequency it would have performed for a similar value. So this is where antenna tuning or having a proper antenna comes into play. So if you have a manual antenna that you have made yourself, let's say a Yagi-Uda antenna or a dipole antenna, you can trim the edges, change the capacitance and things like that, and you can alter the SWR while you're connected to your NanoVNA. So NanoVNA is a pretty interesting tool. Now moving on to the big guns from Rack Wireless. We have the 5.8 dBi antenna, which is rated for 860 to 930 megahertz. This is a LoRa fiberglass antenna and it is a long one. This 5.8 dBi antenna is around 2 to 3 feet long antenna, and this is something that is very much recommended a lot of times for helium mining. So I'll quickly connect this to the VNA. So now I've connected the 5.8 dBi antenna, and you can see that the curve from 500 megahertz to 1000 megahertz is pretty vivid. It's not a straight line and then a sharp valley. It's in totality a valley towards the right hand side of the spectrum, so which means that it is usable at multiple frequencies, but we'll look at the frequency that we most intend to use it at, and it is 868 megahertz. So I'll move it around 868 megahertz. So the closest peak I see is around here, and if I remove my hands off the device, essentially free it from any electrostatic discharge or my earthing that I'm doing from my ground. It's on a wooden table right now. There's no other wires on this table. So if I carefully move it towards 868 megahertz, the closest is 870, and I leave it to rest, there's no human contact with the antenna or with the device whatsoever. So you can see that the SWR is 1.05. I even saw the SWR go as low as 1.03 for this particular antenna, and it is as good as it gets. So this antenna is somewhat ideal for using at an 868 megahertz frequency for your LoRa devices, and it will kind of radiate all the power that it receives from your miner or your LoRaWAN gateway and radiate it into the environment rather than reflecting it back due to being a bad antenna. So this one is the Rack 5.8 dBi antenna, and with my testing, this particular piece is a good one. And I've heard from Rack Wireless team that they pay special attention in tuning to their antennas. So again, that is a good point. To validate that, we have another antenna from Rack Wireless. This one is the 8 dBi antenna. It's in the same frequency range, 858 to 878, and this one is a really long antenna. So this one is a 4 to 5 feet antenna. It cannot fit in the camera frame right now. I'll quickly disconnect the 5.8 dBi antenna and connect the 8 dBi antenna to test it out. So the 8 dBi antenna is now connected to the VNA, and this is how it looks. Again, we'll move it closer to 868 megahertz. This is the closest. The SWR over here is 1.15. I've again seen SWRs as low as 1.05 on this particular antenna. Over here as well, there are some lows. It's a 1.08 SWR over here. We are also interested in this particular frequency because it's showing a good valley in the log mag range as well. So this one is a 1.03, 1.04 at 610 megahertz antenna. So I hope you get the point, where if you're going to use an antenna for a custom application, you connect your antenna to your VNA, you see where is the best or the least SWR that you're receiving, and that is the frequency you use for your antenna. Your antenna will perform the best when its SWR is the lowest or and as close to a one figure of SWR as possible. We have also reached 1.01 right now. That is why in the market, when people are expanding their helium networks, you see a lot of people using these rack antennas, and they do indeed get a good performance on their helium miners. And my advice would remain the same. If you still want to test out your antennas, this is something that you can get as a valid or a handy tool. The link of this VNA will be in the description box below. The VNA comes from the store of Leap IoT. And I hope you understand how you can use a NanoVNA like this to test out your antennas. And with a better antenna, all you get is more range on your LoRaWAN hotspot or any Wi-Fi or radio frequency based device. Essentially, if you're into helium mining, you know the answer. Thanks for watching. Subscribe to our channel if you haven't till now. Also hit the bell icon to stay notified. This is Akash signing off.